I'm starting the recording and let's get started. So, the agenda for today's session is we're going to finish what we weren't able to finish in our review lecture in lecture 26 as promised. I will go over one to two very important things in statistical inference, and then I will go over a few questions in machine learning. Hopefully, this is not going to take us very long as well. For PySpark, I am going to share a recorded demo with you guys. However, I will announce this as well. PySpark key coding will not be tested in your exam. You should know about Spark on a conceptual level as far as what has been covered in your lectures. We will not test coding at all. With that, let's get started. A couple of very important things in statistical inference. Give it a few seconds. Well, there we go. So I quickly want to walk you over the steps that you will follow to assess a model. हमने इसको tutorial 8 में detail में भी देखा था through an example as well, but just so that you should be very well familiar with this. First, you come up with a statistic that helps you decide कि आपने null hypothesis को reject करना है or whether you will fail to reject it. You come up with a test statistic. This helps you decide whether your data supports your model or if it supports an alternative view of the world. A test statistic has to be decided in such a way that higher values of the statistic make you incline towards the alternative hypothesis. This is a convention that we follow. It's in your slides as well. When you're picking a test statistic, you pick it in such a way कि उसकी higher values आपके alternative hypothesis को support करें. Once you do pick a statistic, then you simulate it under the assumptions of your model. Well, what you do is you can very easily write a data generating algorithm. You can do this in code, and then you will simulate thousands of values of your statistic that will help you build a distribution. This is how you build your distribution under the null hypothesis. So, before I go back to the steps, I quickly want to help you recall the null and alternative hypothesis. Well, null is a well defined chance model about how the data were generated. This corresponds to our example of Mendel's model of pea flowers. Just may you have a model that tells you about how the data is generated. Hmm, in simpler words, it means no effect. If you're trying to measure or if you're trying to observe the effect of one variable on another or so, so null by default hota hai कि there is no effect. For instance, I want to study the impact of background music on students' exam performance. So my null hypothesis would be that background music has no effect on student exam performance. You can simulate data under the assumptions under the null model. Alternative hypothesis would be, well, a different view about the origin of the data, that there is an effect. So, with your background music example, your alternative hypothesis would actually be that background music does have an impact on student exam performance. जब आप null define कर लें and आप test statistic define कर लें such that higher values of the statistic are supporting your alternative hypothesis, then you will write an algorithm to generate data under the assumptions of the null model. Null के अंदर आप data generate करते हैं, you make a histogram. When you draw this histogram of simulated values, this is the model's prediction for how the statistic should come out. These are the first three steps. Once you have this distribution generated, तो अभी तक आपने data को synthetically generate किया. You've generated data under the assumptions of the model, you've plotted data. Now there is a value that is coming to you from nature. This value is your observed test statistic, जो actual में आप measure कर रहे हैं. You will plot this observed
हाँ, मैम।
statistic. Yeah.
आपकी आखिरी बात मुझे आप दोबारा रिपीट कर देंगे कि अगर हम किसी चीज़ का इफ़ेक्ट स्टडी कर रहे हैं तो नल हाइपोथेसिस वुड बी द रिजेक्शन ऑफ दैट मतलब ऐसा
नल
है? आपने
हाइपोथेसिस
बोला था ना?
आपको ये बताएगा कि आप जो इफेक्ट मेजर कर रहे हैं वो इफेक्ट नहीं एग्जिस्ट करता। टिपिकली जो हम टेस्ट्स पढ़ते हैं विद इन द स्कोप ऑफ दिस कोर्स, उसमें आप एग्जैक्ट इफेक्ट नहीं मेजर कर रहे, उसमें यू आर जस्ट मेजरिंग वेदर एन इफेक्ट एग्जिस्ट्स और नॉट। मेक सेंस? तो नल
हुँ।
आपको ये कहेगा कि नो इफेक्ट एग्जिस्ट्स एंड ऑल्टरनेटिव विल टेल यू कि देयर इज एन इफेक्ट या देयर इज अ स्टेटिस्टिकली सिग्निफिकेंट इफेक्ट। मेक सेंस?
ये हमेशा ट्रू होगा ना? ये वाली
um
कंडीशन?
I'm sorry, what would always be true?
कि जो नल होगा वो कहेगा कि देयर इज़ नो इफेक्ट एंड द अल्टरनेटिव विल से कि देयर विल बी एन इफेक्ट।
Yes, yeah, you are right. This will be true. So इसलिए जब आप
सही
अपनी
है, थैंक यू।
स्टेटिस्टिक को पिक करें, यू पिक इट इन सच अ मैनर कि उसकी हायर वैल्यूज ऑल्टरनेटिव व्यू को सपोर्ट करें. So when you make this histogram, तो फिर you plot your histogram and then you compute the observed statistic from your sample. And once you have your observed statistic, तो आप उस observed statistic को अपनी distribution से compare करते हैं. Either your observed value is consistent with the distribution or it isn't consistent with the distribution. If it is consistent, so you fail to reject the null hypothesis. If it is not consistent, then you reject the null hypothesis. Either you have evidence against the model or you don't have enough evidence against the model. इसकी एक एग्जांपल हमने देखी थी मेंडल्स मॉडल ऑफ पी फ्लावर्स की, एंड आई विल शो यू अनदर एग्जांपल एज वेल. Oh, of course, one important thing is कि अब ये जो consistency है, इसकी notion को हम खुद define करते हैं. Of course, the farther your observed statistic is from your null distribution, the more evidence you have against the null hypothesis. लेकिन किस boundary के ऊपर आपने cutoff लगाना है, you define that yourself. You define that on the basis of your significance level. For now, we're going to look at an example, and this is an example. This is from a past exam question, and I want you all to be well familiar with what is happening over here. A lot of people got this wrong. So, this is the scenario that is given to you. We are studying whether course format, online versus in person, impacts test scores. The effect could go in either direction. In person students may score higher than the online students, or online students may score higher than the in person students. Otherwise, there may be no difference at all. So you have to state the null and the alternative hypothesis. I'll give you a few seconds to think here. If someone can volunteer a solution, that would be great. Otherwise, I'll just show you.
Within this, can we just take one as null and the other as alternative since there isn't, I mean, the effect can go in either direction. It isn't that something is affecting or not affecting.
You have to state the
Mm.
null and the alternative. मुझे आपकी बात clear नहीं है. आप state करें फिर मैं बताती हूँ.
So if we take null as in person and alternative as online, isn't that the same as taking null as online and alternative as in person
अच्छा,
in
the
this
thing is कि
particular example?
आप किसी एक format को नहीं pick कर रहे as the null or as the alternative. See, आप अगर if we look at the first line,
Mhm.
तो हम कह रहे हैं कि we are studying whether course format impacts test scores. This gives it away. It means कि either course format impact करेगा scores को
Oh,
या वो
okay.
नहीं impact करेगा. Make sense?
Okay, okay,
This
makes
is a
sense.
common
Yes, makes
mistake
sense.
actually.
Okay, yes, makes sense.
उसके बाद आपको बताया है कि the effect could go in either direction. तो you're not measuring कितना effect है या किस direction में effect है. Sorry, you're just measuring कि effect है या नहीं है. So this is going to be your null. Course format has no impact on test scores, and your alternative is कि course format does have an impact on test scores. जो नीचे आपको दिया हुआ है, this is the data that is available to you. Let me quickly walk you guys through this as well. आपको group given है और आपको score given है. So जो O group है, that represents the people that were studying online. जो I group है, that represents the people that were taking classes in person. और आपके पास इस तरह data available है. This dot just tells you कि you have a lot more values for this available. So this is the data that is available to you. अब इस data को use करके हमने evaluate करना है. So that was the first part. By the way, when you do this, जब आप null and alternative को state करें तो आप इन्हें test statistic की terms में भी state कर सकते हैं. But first you have to define a test statistic. So I will define this for you over here क्योंकि उस पे separately question नहीं था over here. So what you will do is कि you will take the mean score of students that were studying online and you will take the absolute difference of that and the scores of students that were studying in person, unka mean score. So the mean of people studying online minus the mean of people studying in person, आप इसका absolute ले लें because the effect could go in either direction. Now the thing is कि हमारा null hypothesis कह रहा था कि there is no impact. So that means कि इन दोनों के mean scores should be equal or the difference in the mean scores of these two should be equal to 0. तो अगर आप इसको इस format में state कर दें तो that's obviously acceptable as well. Anyway, the thing about this test statistic is कि इसकी value close to 0 होगी if the null is true. And इसकी value जितनी high होगी उतना alternative को ये favor करेगा. So just to show you कि this is how you pick a test statistic. I will also highlight over here कि there is not always one test statistic that is true. It's not like I give you a situation and there is only one right answer for the test statistic. You just have to take a statistic जिसकी higher values alternative को favor करें. That helps you study this effect. With that, moving on, what statistical test should be used? Would someone want to comment on this or should I just show you what we're actually अब मैंने गलती से दिखा ही दिया है तो I'm just gonna tell you. You're using a permutation test for this. Very
Shiza,
specifically, yeah,
sorry to cut you off. I just wanted to
no worries.
ask कि उससे पहले, like if we don't take an absolute value, if we just square it, is that like still acceptable?
Yeah, that's acceptable. क्योंकि आप
Okay,
देखिए
okay,
आप
ठीक
उसको
है.
अगर लाइक मीन्स का डिफरेंस लेके स्क्वायर कर लें तो भी दैट काउंट्स फॉर
Hmm.
द इफेक्ट गोइंग इन ईदर डायरेक्शन राइट. और ये जो टेस्ट स्टेटिस्टिक आपने लिया है
Okay,
इसकी
okay.
वैल्यू जितनी हाई होगी उतना ये ऑल्टरनेटिव को फेवर करेगा. तो या दैट्स एब्सोल्युटली अ वैलिड आंसर हियर.
Okay, perfect. Thank you.
If we ask you what the statistic is, so there won't always be just one right answer. या इसको बस आप खुद पिक करते हैं as part of your study design. Okay, so moving on, I have asked you what statistical test should be used over here. The correct answer is permutation test. So यहाँ पे एक question ये था कि how will you generate data under the null distribution? How will you generate data under the null hypothesis? क्योंकि पहले you want to do that, right? So, uske liye specifically, we are gonna use a permutation test. So, I want to show you why a permutation test works over here, and then I will show you one alternative answer जो काफी students ने दिया हमें, and I will tell you why that does not work. So, how will you use a permutation test here? What do you do in a p-test? P-test में आप labels shuffle करते हैं. In order to assume that the null is true, what I can do is कि मैं ये i's और o's की values को shift कर सकती हूँ. I can just shuffle the values of i's and o's. It doesn't matter कि मैं इसको O group में assign करूँ या I group में assign करूँ एक score को. I'm assuming कि कोई difference ही नहीं है. One example that you did for this in class was the baby weights example, where you were trying to understand whether mothers who are smoking when they're expecting their babies is something that is impacting the weights of those babies at birth. In which case, you have, some data given to you आपको गिवन है whether the mothers were smoking or not, and you are given the weights of their babies at birth. Under a P test, आप null के अंदर assume करते हैं कि कोई effect नहीं है, इसलिए I just swap those labels, I shuffle those labels. Once you shuffle those labels एक दफा तो you generate one permutation. फिर उस permutation के लिए आप test statistic की value को compute करते हैं, तो that's exactly what you will do over here as well. फिर आप एक और permutation करेंगे जिसमें again you will shuffle all these labels. You know, you are using your existing data. You will shuffle all of your labels again and you will compute the test statistic again. So test statistic compute करने के लिए तो सिर्फ मैं अपने ग्रुप में से O's वाली values निकाल रही हूँ और मैं उनका mean लेती हूँ. Then I take the I values and I take their mean. Then I take the absolute difference of these means, or like you mentioned, आप square difference का square भी ले सकते हैं, whatever it is that you're using as your statistic. Anyway, so for each permutation you calculate the value of your statistic. ये process जब आप repeat करेंगे 1,000 times or 10,000 times, तो you will be able to generate a distribution, and that is essentially what your data will look like under the null distribution. So this is what I want to show you over here as well, because we've done this in code. So आपके पास group given है और score given है. मैं इसकी permutations generate करूंगी सिर्फ groups के labels को swap करके. And then this is how I will compute the mean of scores for each group. इनका मैंने difference ले लिया. This is how I've made this distribution. So ignore the red line right now. बाकी ये distribution मैंने plot की है. After taking, I think I took 10,000 permutations over here, but I will show you in code as well. So this is what my null distribution will look like. I have steps written down over here as well. You can quickly go through these. You compute the observed difference in a statistic. For instance, हमने difference in means को choose किया था. Then you shuffle the label as many times, and for each shuffle, you compute your statistic again. Then you build a distribution of these permuted differences or your statistic. फिर आपने जो पहले स्टेप में compute किया वो आपका original observed test statistic था. Like I told you, there is one thing that is observed. मतलब ये data as it is रख के without shifting any labels, if you compute the test statistic की value, तो that is your observed test statistic. वो आप step 1 में compute करके रख रहे हैं या आप उसको end में compute कर सकते हैं. There is no particular order to that. फिर उस observed value को आप अपनी original null distribution से compare करते हैं to get a p-value. I will help you recall what a p-value is as well. Anyway, so now if we come to this red line, तो इस red line से मैंने इस graph के ऊपर actual observed difference को mark कर दिया. Observed difference is something that I found over here, exactly इसी data में without any permutation करके, without any shuffling करके मैंने जो observed test statistic निकाली थी, that's plotted over here. Right now it's so evident कि आपकी जो observed statistic है, it is so far from your distribution. Okay, this tells you you have a lot of evidence, you have strong evidence against the null, which means you're gonna fail to reject the null hypothesis. I hope this makes sense. Are there any questions at this point?
No, everything makes sense.
Perfect. Um, I will not go over alpha, power, p-value, critical value in detail again. For that, I will recommend कि अगर आपको clear नहीं है तो एक दफ़ा ज़रूर revisit tutorial number 8 के contents, I believe. Yeah, tutorial 8 was on statistical inference. In this case, if someone would like to comment on the p-value for this, that would be great. So I will quickly highlight कि p-value क्या होता है. P-value is the area under the null distribution where the value of the statistic is greater than the observed difference. मेरी null distribution सारी यहाँ पे है और observed statistic यहाँ पे है, तो my p-value is actually just 0% because null के अंदर कोई भी area नहीं है जो इस statistic से ज़्यादा हो. सो जितनी छोटी आपकी पी वैल्यू हो उतना ज्यादा आपके पास एविडेंस होता है अगेंस्ट द null. Anyway, this is one very common answer that we received to this question, bootstrap sampling. You cannot use bootstrap sampling over here to generate the null distribution, and I want to show you why bootstrap fails over here. So I will show you a piece of code as well. Like when I try to do bootstrap sampling, this is what the distribution comes out to look like. अगर मैं इसके ऊपर ऑब्जर्व डिफरेंस को प्लॉट करूं तो मेरी तो ऑब्जर्व्ड स्टेटिस्टिक की वैल्यू फॉल्स इन द मिडल ऑफ द डिस्ट्रीब्यूशन, which tells me that I don't have enough evidence to reject the null. The thing is that bootstrap sampling is I'm not able to identify an effect, even though an effect exists using bootstrap sampling. Because the primary problem is that bootstrap sampling is not assuming that the null is true by default. It fails to identify a difference when it exists since it does not assume the null to be true. And this is the thing, इस डेटा के अंदर इसके अंदर वो लेबल्स को शफल नहीं करता, वो पूरे टपल्स को शफल करके उनकी परम्यूटेशंस निकालता है, in which case जो इफेक्ट है it still stays in place. The same thing that was in your original data is reflected in this distribution. We will not go into the detail of this code, but I will show you over here as well. Okay, I generated data. I generated 5,000 rows in this format. ये मेरा generated data है where I have the scores for group O and the scores for group I. I have generated this data systematically such that मैंने certain values के around scale करके उन्हें generate किया. तो I already generated my data to make sure कि group O वालों का जो mean है वो कम हो group I से. This I did intentionally, which means that there is an effect. I'm gonna try and identify that effect then. So मैंने 1,000 permutations generate ki. I could have generated more permutations. And I did that by using NP ka permute ka function, permutation ka function. This is what came out. Alternatively, when I did bootstrap sampling, तो मैंने permute का function नहीं use किया, मैंने पूरे groups के अंदर से random samples generate कर लिए. And this is what I see. So, anyway, this is why this will not work for you. Are there any questions up until this point? All right.
Could you repeat
Yeah.
the last thing that you said, please?
Why bootstrap sampling fails?
Yes.
I think there's a small problem. वो ये कि my entire screen was not presented, so I don't think that you guys would have been able to see this code. Can you see my screen?
Now we can.
Yeah, this was a little problematic. So I will tell you what's happening again. इधर मैंने डेटा जनरेट किया था माय ओरिजिनल डेटा फ्रेम, और मैंने डेटा को सिस्टमैटिकली इस तरह जनरेट किया था कि आई इंश्योर्ड के ऑनलाइन का मीन कम्स आउट टू बी अराउंड 78 with the standard deviation of 5, and in person का मीन comes out to be 85 with the standard deviation of 5. This I did intentionally, and I did this intentionally ताकि मुझे पता हो कि एक इफेक्ट एग्जिस्ट करता है. एंड देन आई रोट सम कोड टू रन अ पी टेस्ट, एंड देन आई रोट सम कोड टू डू बूटस्ट्रैप सैम्पलिंग, एंड आई सॉ कि किस टेस्ट ने उस इफेक्ट को डिटेक्ट कर लिया सक्सेसफुली. सो दिस वाज माय डेटा फ्रेम. इस डेटा फ्रेम को यूज करके यहाँ पे मैंने ऑब्जर्व्ड मीन्स निकाले, और इन ऑब्जर्व्ड मीन्स का डिफरेंस अगर मैं निकालूं तो दैट इज माय ऑब्जर्व्ड स्टैटिस्टिक. That is gonna come out to be 7 point something. This is where I run a permutation test. So मैंने 1,000 permutations निकाली. For each permutation, I use NP का permutation का function to shift group के labels की values. And then for each permutation, I compute my test statistic. Then I store my test statistic somewhere. Then I make this graph. This is what it comes out to be. And this is very nicely detecting an effect as well, since an effect exists. When I try to do bootstrap sampling on the other hand, see मैंने 1000 ही bootstrap samples भी generate किए, but now I'm using np.random.choice और मैं एक certain proportion के अंदर सिर्फ दोनों groups में से samples extract कर रही हूँ. I am not shifting the labels. पीछे code के अंदर I was shifting the labels as well. So इस तरह I take out my choices. For each choice, I compute the difference and then I plot the distribution of differences, and this is what it looks like. Since इसने null को assume नहीं किया, इसीलिए जो मेरे पास plot बना है, that is reflective of what was in my original data set. That's why it is still centered around the difference that already existed. So this is not giving me the proper null distribution. इसीलिए I'm failing to observe an effect. अगर ये null होता और observe value इसके center में होती, तो obviously I would fail to reject the null, even though in this case I want to reject the null. Is that clear now? Are there any questions?
I wanted to ask, is there any way to have bootstrap sampling where we do assume the null?
बूटस्ट्रैप सैम्पलिंग को यूज करके आप नल डिस्ट्रीब्यूशन को इस तरह जनरेट नहीं कर सकते. मतलब यू कांट डू दैट यूजिंग योर ओन डेटा, क्योंकि उस डेटा को यूज करके
Hmm.
आपने ऑब्जर्व्ड स्टेटिस्टिक को कंप्यूट करना है. मे बी अगर आपके पास well, this is a little tough actually. If you're synthetically generating data under the null और आप उसमें से samples और resamples करते जाएं तो that makes sense. But essentially
Hmm.
that's not bootstrap sampling though. Bootstrap तो तब आप use करते हैं जब आपके पास data कम available हो, but एक अच्छा representative data set हो तो you just sample from your samples. उसको आप
Okay,
एज अ
okay, makes sense.
स्टैटिस्टिकल टेस्ट या नल जनरेट करने के लिए नहीं यूज कर सकते. आई होप दैट मेक्स सेंस.
Yes, yes, it does.
Yeah,
Thank
so
you.
this is no worry. So this is something I specifically wanted to put in the review because people have struggled with this in the past. So with that, I hope that that is clear. उसके अलावा आप लोगों ने दो तीन statistical tests देखे हैं, a t test, a z test. But essentially, these are not going to be tested. You should just know that these tests, they do exist. And that's all that you should know. We're going to move on to machine learning. As promised, we're going to do 2 to 3 practice questions involving math. And then there are some questions that I want to cover with you with regards to classification matrix that you covered and when you're going to use each. This part I encourage everyone to try and attempt on their own as well. Yeah, at least do think about this. This is gonna help you since we haven't covered a lot of practice material in this area up until now. So there are 2 to 3 concepts that I want to quickly go over in machine learning. First, your bias variance trade-off and the idea of regularization. जो आपको first model दिया हुआ है, this is an example of a model that is overfitting. See, the thing is that it very, very specifically fits to every single data point that is given to you. We don't want a model like that because when we give it new data, so it will fail to generalize to your new data. On the other hand, जो आपको इससे next model दिया हुआ है, this is a model that has underfitted on your data. ये ट्रेनिंग डेटा को ही अच्छे से फिट नहीं हुआ तो ये टेस्टिंग डेटा पे भी अच्छा नहीं परफॉर्म करेगा. द थर्ड इज अ गुड बैलेंस. दिस इज अ मॉडल दैट हैज नाइदर ओवरफिटेड योर डेटा नॉर अंडरफिटेड योर डेटा. दिस इज व्हाट वी ट्राई टू एज्यूम. जो फर्स्ट वाली एग्जांपल है उसमें यू हैव हाई वेरिएंस. जो सेकंड एग्जांपल है उसमें यू हैव हाई बायस. जो थर्ड एग्जांपल है उसमें यू हैव अ डिसेंट बैलेंस बिटवीन बायस एंड वेरिएंस. What is evident over here is, well, bias is telling you कि in actual values से आपकी predictions कितनी ज़्यादा distant है, and variance is telling you about how well your model is generalizing. If I try to for instance कि overfitting वाले में मेरे पास high variance है, अगर मैं इसमें variance को कम करने की कोशिश करूं तो bias बढ़ जाएगा. So that's why I have to find a good balance over here. I hope that this idea is clear to you with regards to this example. And then regularization is something that you use to find a good balance between bias and variance. This is what we use. So, regularization is something that prevents overfitting, it improves generalization. How does it do so? It introduces a penalty on the complexity of the model. Because in तीनों diagrams में हम देख रहे हैं कि three models हैं आपके पास different complexity levels के. जो first वाला है उसमें your model is so complex कि it has just memorized all your data. The second wale mein maybe your model is too simple. So we try to find a balance. So regularization is something that's introducing a penalty on the complexity of your model. It encourages your model to be simpler and to be less prone to overfitting. क्योंकि आपके model के अंदर there are certain parameters that your model is running on the basis of. So regularization में ये होता है कि हर parameter के ऊपर आप एक penalty term introduce कर देते हैं. So अगर ये वाला पैरामीटर लर्न था द वन दैट्स के पैरामीटर्स लर्न थे जो फर्स्ट एग्जांपल के मॉडल में रिफ्लेक्ट हो रहे हैं आफ्टर सम पेनल्टी मे बी आई विल बी एबल टू फाइंड अ गुड बैलेंस लाइक यू कैन सी इन योर थर्ड एग्जांपल. And this is how that works. So I am fitting my data. This is my loss function. जो theta hat है, this is just how I am. Well, this is going to be the जो आपने penalize करना है अपने model को. You have the loss function. You are taking the average loss. Then for each theta, you are adding a regularization parameter. उसको आप add कर रहे हैं to your model weight. You are penalizing your complex models. R theta is the output of that regularization term. Lambda से ये multiply हो रहा है and lambda tells you about how harsh you want that penalty to be. So lambda की value जितनी ज़्यादा होगी उतना आप ज़्यादा penalize कर रहे हैं अपने model को and lambda की value जितनी कम होगी उतना कम आप penalize कर रहे हैं अपने model को. This value of lambda is what is helping you determine the bias variance trade-off. If it of larger values will ensure more regularization, लेकिन ज़्यादा values से bias increase होगा, although variance will decrease. So you still have to find the right balance. Secondly, there are two kinds of regularization that you have covered in class. I want to show you the formulations of each, and I want to briefly walk you over the difference between each here as well. So this is L1 regularization. L1 regularization is also called lasso regularization. Lasso के अंदर आप क्या कर रहे हैं? आप सिर्फ penalty term के लिए you are only computing the average value of your parameters. आप सिर्फ parameters की average नहीं absolute value ले रहे हैं, which means कि only where the terms are negative they're going to be turned to positive. This is how it looks like graphically. This is something that is encouraging sparsity in your model. It will push some of your model weights to zero because if you take this term और फिर आप इसको add करें so some of your model weights might be pushed to zero. This is something that helps you with feature selection. I will show you through a visualization how this works as well. So this can be useful in high dimensional data sets where a lot of features may be irrelevant. How does this help with feature selection? जिन features के लिए parameters की values will be pushed to zero, those features will automatically be eliminated from your model. So this is often used when you want to use a simpler model, when you want to reduce the number of influential features. Then you have ridge regression. Ridge regression ki graphical representation is given to you as well. And here, instead of taking the absolute value, you are taking the square of each theta. Since you are taking the square of each theta, तो आपका कोई भी जो weight है उसकी value zero को नहीं push होगी. लेकिन what will happen is कि it will reduce the weights though. Weights smaller हो जाएंगे, लेकिन you are not forcing them to be exactly zero. So this is going to smooth out the model. This is going to reduce the impact of any single feature over the other. This is going to prevent your more dominant features from dominating too much. This is not going to help you with feature selection. This is what you use when you want to prevent large weight values and when you want to reduce the risk of overfitting. This is what I've given to you as an example. So if you look at your baseline, ये आपके पास parameters हैं which I have highlighted. In a matrix of black and white, the darker values were, well, they were bigger, the lighter values were smaller. L1 regularization के बाद काफी values इसमें से white हो गई हैं. These were the parameters that were penalized enough to push their values to zero. And others have, well, they've gotten darker, they've gotten bolder. L2 regularization mein, I'm not pushing anything to zero that wasn't already zero, but since a lot of my values are lighter, so I'm just ensuring that my weights are slightly smaller now. So here is what the weight matrices would look like. L1 is sparse with many zeros, and L2 just has slightly smaller weights. Are there any questions about this? Okay, so we're gonna look at this through an example, and for
L2
our
का आपका
example,
एक्सप्लेन कर देंगे?
sorry, come again?
L2 वाला मुझे समझ नहीं आया, वो आप दोबारा बता देंगे उसमें क्या
Sure,
होगा?
sure, why not?
L2
इसको यहाँ से
लेवल।
ओपन कर लेते हैं. Yeah. So L2 के अंदर instead of taking the absolute value आप square value ले रहे हैं. Since आप square value ले रहे हैं, तो आपके जो parameters हैं, they will not be pushed to exactly zero. बस उनके weights कम हो जाएंगे. You're not gonna push the weights to zero, but you're gonna ensure smaller weights. उससे ये होगा कि your model will become more smooth. It will reduce the impact of any single feature, since आप features के weights को कम कर रहे हैं. Um, Essentially, the thing about L1 is that you were using that for feature selection as well. कुछ high dimensional data sets में ये कुछ features के लिए parameters को zero पे push कर देता है. L2 is not pushing them to zero, it's just something that you're using to prevent large weight values. You're using it to prevent the risk of overfitting. अगर ये वाली visualization हम देखें, तो baseline को अगर आप L2 से compare करें, तो L2 is just a lighter version of the baseline. सारे weights आपके कुछ light हो गए हैं. कोई भी weight आपका you haven't pushed it to zero unless it was already zero. L1 के अंदर there are some weights that you push to zero and others that you highlighted more. Does that make sense?
सही है।
Okay. So we are gonna look at an example. अच्छा दोनों के अंदर you are defining lambda. We're gonna look at an example where we'll work this out mathematically as well, because you should know how to do this. So I have this over here. इसका size थोड़ा सा हम increase कर लेते हैं. Is this readable for you all? Let me just zoom in. All right, this is great. Is this readable, guys?
Yes.
Perfect. So consider the following weights and inputs to your model. Weights आपको ये दिए हुए हैं 1.3, -0.5, 3.2, 1.95 and -2. Then you are given three input rows against their ground truths. So this is how it works. Input row 1 जो है उसके अंदर you have 4220, then 3815, then 2071. And these are the ground truths against every single input. You will observe कि weights आपको 5 दिए हुए हैं, even though inputs के अंदर आपके पास 4 values हैं. So this is what you're also told, that the first weight belongs to the bias term. You are given the regularization parameter as 7, and you're going to calculate the value of the objective function to be minimized for lasso regression. Let's recall over here that lasso regression was L1, all right? And you're going to use the mean squared error as your loss function. Um, I will encourage you to have a pen and a notebook or something with you, and I will give you a few seconds here. All right, so हम y की predicted values को निकाल रहे हैं. Ground truth आपको दी हुई है. This is what y1, y2 and y3 looks like. The well, the notion that you use is y hat. Well, I can't do that over here, so I am just gonna do it like that. 1, and then you will compute the second, and then you will compute the third. We are going to compute our predicted values, which is fairly simple क्योंकि weights आपको दिए हुए हैं. जो initial वाला weight है bias term का, उसको आप simply add कर लें. 1.3 plus, and then I will take my next weight, which is minus 0.5, and I will multiply that with my first term, which is 4. I'm just looking at input row 1 right now. Then I will take the next weight, which is 3.2, and I will multiply that with, well, what I have over here, next input feature, which is 2. So this is the list of features given to you, feature values हैं आपके पास. Then I will take the next one, which is 1.95, and I will multiply it with my next feature weight, which is, sorry, feature value, which is 2. Then you'll take the last one, minus 2, and you'll multiply it with its feature key value is 0. So this comes out to be 9.6. Similarly, you will do this for y2 and you will do this for y3 as well. So I'm just gonna copy this over here and इसमें हम values को update कर लेते हैं. So here, as opposed to 4, I'm gonna look at my next input row now, 3815. So 3, 8, 1 and 5. Similarly, I will look at input row number 3, जिसके अंदर I have 2, 0, 7 and 1. So this will give me 17.35 and this one will give me 11.95. I hope that this is clear so far. इसकी हम type बदल देते हैं so you differentiate the solution from the question itself. So this is what you have so far. Now since I'm using mean squared error, so I will calculate the mean squared error. Against these ground truths, ये मेरे पास y1, y2, y3 की values given है. So when I'm calculating my MSE, this is how I would do so. I will take y1 minus y hat 1. इसका मैं square ले लूंगी since mean squared error है. So this is how I will do that. I can see कि now square is getting confusing with my hat situation. So इसको हम या तो इस तरह ले लेते हैं. I don't want this to be confusing for you. Alright, I will take the square of that. What am I doing? My actual value minus my predicted value square. Then I will take the next one, which is of course y2 against my second input. So y2 minus y hat 2 and then uska square. Then let's take my third one. Once I take all of these, I have to divide them with the total number of terms. So इसको आप divided by 3 कर देंगे. So this is what your MSE will come out to be. Why don't we quickly plug in these values as well? 9.6 minus my initial actual value was exactly 9 square plus my second value 17.35 minus, so my next actual value was 16. Then I will take the square of this plus my third, I've been doing these the other way around. Convention हमने ये वाली follow किया, actual minus predicted. So I don't want this to be confusing for you. The last actual value is 9.5 and the third predicted value is 11.95. So I will take the square of that. And then my answer comes out to be 2.7283. So this is what my MSc is. Are there any questions up until this point? So now I will quickly go back and help you recall कि L1 में this is the function that you were using. इस function को हम यहाँ पे लिख लेते हैं. All right, this was your lasso regression function. So now I actually have to calculate this. At the same time, I want you to be mindful of this as well. कि आपने actually जो loss function calculate किया था, that plus lambda times whatever your regularization function gave you. So इससे जो value आएगी उसको मैंने lambda से multiply करना है. But first, let me just compute this. Well, I don't know how to replace this with lambda, so I'm just gonna write down lambda multiplied by ये आपके पास इसका जो भी output आता है. So let's just write it down like that. So lambda is already given to you as 7. So I will do that here. I could just as well copy this actually. So 7 multiplied by, and this is very simple. I'm just computing the sum of these और इन्हें मैंने add करना है. So sum of the absolute values. So my first absolute value would be, this is for your weights by the way. So my weights are, you are not going to include the bias term in this. You're going to include your parameters. So your parameters were minus 0.5, 3.2, 1.95, and minus 2. So this is what that would look like. Minus 0.5 की absolute value plus 3.2 की absolute value plus 1.95 की absolute value plus minus 2 की absolute value. As simple as that. And this is what the output comes out to be, 53.55. Are there any questions up until this point? So the last step, क्योंकि we have asked you to calculate the value of the objective function that is to be minimized, and objective function के लिए आप सिर्फ इस term को add कर रहे हैं to well the MSE that you have already computed because you were taking your loss, right? आप loss function के लिए ये कर रहे थे. So loss function की value हमने ऊपर find कर लिया 2.7283. So I will take this value and then I will add lambda times my well regularization term to this, and that I have already calculated to be 53.55. So my answer comes out to be 56.2783. I'm gonna slightly zoom out and give you guys a few seconds to go over this. So if you have any questions, please do go ahead. If not, then we'll move on. I would encourage you to try and attempt this for maybe you could do it for a different loss function. Maybe you could do it for L2 regularization as opposed to this one.
मैम ये लैम्डा टाइम्स आर जो थीटा था वो आपने क्या बताया था, क्या चीज है? सम ऑफ द वेट्स.
Lambda times r theta? अच्छा वो आपको ये यहाँ पे गिवन है, ये देखें. इस तरह आप
सही है.
penalize करते हैं. Lambda times r theta plus जो आपने loss calculate किया था. हमने
तो
R को
इसमें आर
define
थीटा
किया
क्या?
था L1 regularization वाला R theta.
सही है.
So yeah, so that's why I
अच्छा
took
अच्छा,
L1
सही सही
वाला
सही.
formula.
तो एसेंशली अगर हम L2 लगाते हैं तो उसके अंदर सिर्फ आर थीटा ही चेंज होगा. दैट वुड
Yeah,
बी द
absolutely. You're right. It would be,
स्क्वायर, स्क्वायर हो जाएगा. सम
yeah,
वेट
perfect.
वेट का स्क्वायर.
जहाँ पे मैंने ये वाला काम किया है, वहां पे मैं essentially ये कर लूंगी for every single term. So you are right. अगर लॉस फंक्शन आप चेंज करेंगे तो उसके लिए ये ऊपर ये वाली कैलकुलेशन आपकी बदल जाएगी. फॉर इंस्टेंस अभी हमने MSE निकाला है, बट इफ यू वर टेकिंग MAE इंस्टेड, मीन एब्सोल्यूट एरर, तो फिर ये चेंज हो जाएगा. आर देयर एनी अदर
और लॉस
क्वेश्चंस?
फंक्शन दिया
या
होगा हमें जो आपने पिछली स्लाइड में दिखाया था, वो दिया होगा.
आई मीन दैट रियली डिपेंड्स, दैट्स हार्ड फॉर मी टू कमेंट ऑन. ये तो क्वेश्चन पे डिपेंड करेगा ना. यू शुड बी
लाइक
फेमिलियर विद द लॉस फंक्शंस जो आपने पढ़े हैं इन क्लास.
आप वो स्लाइड दिखा सकते हैं थोड़ा?
Let's discuss this at the very end. Unless आप इस स्लाइड की बात कर रहे हैं.
ये वाली इसके
Oh,
अंदर
okay, okay.
अम, इसके अंदर हम मतलब लॉस निकाल रहे हैं ना, थीटा प्राइम इज द लॉस, ऐसे ही है?
Yeah, yeah, आप लॉस निकाल रहे हैं. आप लॉस को मिनिमाइज करने की कोशिश कर रहे हैं. When I say
हम्म
एक्चुअली ये जो थीटा हैट है, आप अपने पैरामीटर्स की जो ऑप्टिमल वैल्यूज हैं वो फाइंड कर रहे हैं. बट आप देखें उसके आगे लॉस फंक्शन है, उसमें यू हैव आर्ग मिन. आप इस पूरे में
हम्म
आर्ग मिन फाइंड कर रहे हैं. सो द आर्ग्यूमेंट्स ऑफ योर थीटास, थीटास की वो वैल्यूज जिनके लिए इसकी वैल्यू मिनिमम होती है. So this is just it's that's given to you in its general form. You're finding the values of your parameters for which the loss comes out to be minimum across all your data points. Make sense?
सही है। बट मुझे
और वो आप
आर्गमिन की
निकाल रहे
समझ नहीं आई, यहाँ पे आर्गमिन क्या कर रहा है?
हैं. आर्गमिन आपको मिनिमम वाले का आर्ग्यूमेंट बताता है. सो इट्स लाइक लॉस फंक्शन आपने कैलकुलेट किया डिफरेंट थीटास की वैल्यूज के लिए. फॉर इंस्टेंस ये
और
आपको
वो
बता
हमें
रहा है
लाइक
कि
वो थीटा
थीटास
देगा
की
जो
कौन सी
मिनिमम
वैल्यूज
लॉस देगा
पे.
ऐसे?
हाँ एग्जैक्टली, यू आर राइट. सो आप थीटा
अच्छा
की
अच्छा,
उस
सही
वैल्यू
है।
को हिट करना चाह रहे हैं जिस पे लॉस मिनिमाइज हो जाता है. मेक सेंस?
सही है सही है।
ओके. So I think let's move on to the next question then. So this is given to you. Again, I will give you guys a few seconds to go through this one as well, and then we'll attempt it together too. So you're given the following weights and inputs. आपको weights दिए हुए हैं 0.5, 1.6, 1.1, -2.3 and -0.1. Once again, जो पहला weight है वो bias term का है और बाकी आपके parameters के weights आपको दिए हुए हैं. You're again given 3 input rows and you're given 3 ground truths. Now you are actually doing classification. आपको ground truths भी classes की दी हुई हैं. And this tells us that you're doing binary classification क्योंकि you have 0 1 outputs. You are going to calculate the इसको इतना part इसका पहले देख लेते हैं. This I've given for your information. You are going to be using this over here. You're required to calculate the loss if you use logistic regression on this data. Without thresholding. Thresholding में आप different thresholds लगा के देखते हैं whether you're gonna count your value as positive or as negative. I will show you later as well. And you're gonna choose a loss function of your choice. So for your information, I am gonna tell you कि this is what you will be using. जो आपको ये वाला loss function given है, this is for your cross entropy loss. For classification, we use cross entropy loss because I will just show you over here as well. इसके solution का सिर्फ हम ये वाला part एक दफा देख लेते हैं, then we will solve the rest together. So the thing is that you're going to use mean cross entropy loss. This is a more appropriate choice when we're doing classification. This is a more appropriate choice than MSE for logistic regression because your squared loss is going to have a non-convex surface. I suppose you've covered this in class as well. If you look over here, तो जिस लॉस की कन्वेक्स लॉस सरफेस है उसके ऊपर I have one minimum point and my algorithm is gonna find that point, then my model is gonna find that point. Non-convex function के अंदर I have local minima, I have global minima, I have saddle points. So we use mean cross entropy loss when you were doing logistic regression. This formula is given to you over here, and if this were to be tested, तो आपको ये formula दिया भी होगा. We will probably make an announcement for this one actually, for with regards to the formulations and stuff. Okay, on that note, moving on, now that we have defined our loss function as well, तो हम इसको calculate करेंगे. First of all, of course, you would want to compute your outputs. जो यहाँ पे आपके पास हो रहा है वो आपका लीनियर मॉडल है. I will just quickly tell you what this represents as well. आप आउटपुट्स निकाल रहे हैं. दिस इज हाउ यू फाइंड द आउटपुट्स. ये जो आपको फाई ऑफ एक्स टी थीटा गिवन है, दिस इज ओवर अ सर्टेन पैरामीटर वैल्यू. यू आर फाइंडिंग द आउटपुट यूजिंग अ लीनियर मॉडल. लीनियर मॉडल मीन्स के इन वेट्स को सिंपली मैं मल्टीप्लाई करूंगी अपनी इनपुट्स के साथ, बायस टर्म को मैं ऐड करूंगी और लीनियर आउटपुट निकल आएगा मेरे पास. दैट लीनियर आउटपुट देन गोज इनटू योर जो आपके पास ये बाहर वाली साइड पे फंक्शन है, दिस इज योर sigmoid फंक्शन, एंड दिस इज व्हाट योर sigmoid फंक्शन इज. 1 डिवाइडेड बाय 1 प्लस ई टू द पावर माइनस जो भी आपके पास अपने लीनियर फंक्शन की आउटपुट आई थी. Well, this is something you should be expected to know as well. So anyway, let's compute it. सबसे पहले आप simple अपने linear function की values निकालेंगे. So this is how I will do so. When I am trying to find, hmm, इसके लिए एक convention followed है. I'm gonna follow it over here as well. You don't necessarily have to stick to it. But I will denote using z instead of ये जो आपको phi से represented है, the outputs of your linear model. So z1 is input row 1 के against जो output आता है. So that's very simple. I will simply add the bias term and then I will take every single weight and I will multiply it with my feature value, corresponding feature values. So 1.6 times 6 plus 1.1 times 3. This is exactly like I did in the previous question. मैंने input row 1 ली है और मैंने weights लिए हैं. So plus minus 2.3 times 1 plus minus 0.1 times 2, and this will give me z1 की value which comes out to be 10.9. So ये मेरे linear model का output है. This is essentially ये जो phi x t theta आपके पास निकल रहा था. I'm gonna break it down for you. अब अगर मैंने इस value को sigmoid में substitute करना है तो that's how I will actually get y hat, जो y की मैं first predicted value निकाल रही हूँ. So this is how I will do that. 1 divided by 1 plus e to the power minus this value. See, ये minus 5 जो output आपके पास निकला था linear model का. So minus 10.9. This is how I will compute the first predicted value, which comes out to be 0.99998. Then I will compute the next one. So I'm just gonna copy this here, 2, and you will take the second input row for that, which is 4, 1, 3, and 5. So 4, 1, 3, and 5. This gives you 0.6. And again, इसको substitute करते हुए मैं minus से multiply करूंगी, so minus 0.6. The answer comes out to be 0.6457. Let's compute the third one then, the third and the last one. You're gonna look at input row 3, 4, 2, 4, 1. So 4, 2, 4, and 1. This gives you an answer of minus 0.2. So यहाँ पे आप minus के साथ उसको substitute करेंगे, which means कि ये plus 0.2 हो जाएगा then eventually. This gives me a result of 0.4502. So now I've computed essentially all of my predicted values. So ये आपके पास सारी predicted values आ गई. Since I use a sigmoid function, so my values are bounded between 0 and 1. And this is essentially why I use a sigmoid function. मैं इन values को use नहीं कर सकती क्योंकि I really want to check for whether I want to check for 0 and 1 labels. I'm doing classification, तो मैं इस वैल्यू को लेके sigmoid फंक्शन में डालती हूँ to activate it, to bound it between 0 and 1. जब वो 0 and 1 के बीच में आ जाता है, तो then I can apply a certain threshold in logistic regression. For instance, अगर मेरा threshold 0.5 होता, तो 0.5 and above वाली को मैं 1 class का label दे देती, in which case ये 1 होता, ये 1 होता और ये 0 class होता. So this is why you use a sigmoid function over here. But for now, we're gonna look at we're gonna need to compute our loss. So I will just highlight the ground truths over here because we will be needing these. These were essentially your ground truths. And well, now you are going to be computing your loss. तो loss के लिए आप simply इसके अंदर plug in ही कर रहे हैं, even though this equation looks scary to you at first, but we have all of our values. This is just a matter of plugging in for us at this point. I will show you how you will do that. So your loss is gonna be equal to, let's be mindful कि n में आपने इसको 3 से divide करना है, your total number of data points, because you're computing the average entropy loss, the mean cross entropy loss. For every single data point though, this is the operation that you are performing. So I am taking yi, मैं ले रही हूँ yi is my ground truth, and for the first example, my ground truth was 1. So मैं 1 को लूंगी and then I will do 1 multiplied by, well, log of, well, 1 को तो actually लिखने की भी ज़रूरत नहीं है. So log of this thing, and this thing was what? It was my predicted value जो यहाँ पे आई थी first input के लिए, 0.tetra98. This thing, and then I will do minus 1 minus yi, and since yi was equal to 0, तो ये वाला part इसका वैसे ही आपके पास 0 हो जाएगा. I don't need to write this down then. Just give me 1 second. Let me clarify this to you guys as well. But there seems to be a small difference over here. This is what you are using. This is what you are using over here. This is the formulation used over here. Let me double check and get this back to you guys. In the meantime, though, I do want to quickly walk you over this one example. We're not going to compute all the matrix for this, though. I just want you to understand how thresholding works through an example. So Ahmed has created a new spam email classifier that he's very proud of. To impress the rest of the TAs, he tested it out on a small data set of 10 emails. The following table gives the output score of his classifier and the ground truth. So this is what I want to show you. Okay, for every single data point, Ahmed की ये output है. Like we saw, sigmoid apply करने के बाद, your output will be, it's gonna be bounded between 0 and 1. This is given to you as the ground truth. Is the email really spam or not? So ground truth may either you have y or you have n available to you. Y means, well, obviously 1 and n means 0. ये आपकी 0 1 classes को represent कर रहा है. If you set the threshold to 0.1, तो जो भी आउटपुट की वैल्यू 0.1 या उससे ग्रेटर हैं उन्हें आप 1 का प्रिडिक्टेड लेबल दे देंगे. जो 0.1 से कम है उन्हें आप प्रिडिक्टेड लेबल देंगे 0 क्लास का. Similarly, when you move the threshold to 0.3, so for all the values that are greater than or equal to 0.3, you will set them to 1 and you will set all the rest to 0. And then the same thing you will do with 0.5. So I want to show you that this is what his output looks like then. 0.1 के threshold के ऊपर all of my values actually come out to be true. All of my values come out to be 1. जब 0.3 का मैंने threshold set किया है तो some of my values now actually turn out to be false as well. Similarly, when I set the threshold to 0.5, तो more of my values are gonna come out to be false. If someone can quickly tell me, because we will not go into a lot of detail for this, what a true positive represents over here. What do I mean by a true positive? So this is very important. True positive वहां पे हमने लिखा है जहां पे the ground truth was 1 and the predicted label was also equal to 1. True negative आपने वहां पे लिखा है जहां पे the ground truth was 0, it was false, and your output also came out to be false, which is why it's true and it's a negative value. Similarly, false positives are those values jahan pe the ground truth was negative, but your model falsely labeled it as positive. Similarly, false negatives are those values jinki ground truth positive thi, 1 thi, but your model falsely labeled them as negative. You should be able to identify these. We're going to look at classification matrix for these as well. I will go back to this one as well. Choice को हम कर चुके हैं justify, or I will share the clarification with you. But there's one important question that I do want to go over with you though. इसकी हम सिर्फ एक iteration देखेंगे, but this is also something that you should be well familiar with. So anyway, you're given a linear relationship f of x equals ax plus b. You want to minimize the following cost function for n training samples. ये cost function objective function आपको दिया हुआ है. Assume that n equals 4. Well, this means that 4 data points are given to you in your data set. And आपके पास pairs given है for, well, a and b, a comma b के format में आपके पास given है. You are also given, sorry, not a comma b, x comma y, in which case y is just f of x. तो इसको इस format में लिख लेते हैं. Y equals f of x equals ax plus b. So you're given x, and for each x you're given the expected y, जो actual y है, ground truth. A and B are the parameters of your model. You're also given the initial values of A and B, which you may assume to be, which are equal to 1. You're given the learning rate, which is 0.05. You have to update your parameters by performing 2 iterations of the gradient descent algorithm. इसके लिए कुछ चीज़ें आपको दी हुई हैं, and you can assume कि वो आपको दी ही होंगी. I will walk you over how you will apply this though. You're gonna do 2 iterations. I will do just 1 iteration with you right now because there is other content that I want to cover. In order to apply the gradient descent algorithm, well, I don't have it open in front of me right now, but I will tell you this much. कि एक अगर आपके पास parameter है, so this is kind of how it works. New value of parameter 1 will be equal to old value of parameter 1 minus learning rate multiplied by partial derivative of parameter 1 with respect to your objective function. This is what your gradient descent equation is. ये आपको दिया हुआ है. यहाँ पे नहीं दिया हुआ, unfortunately, but this is, you should be familiar with this. This is given to you in your slides as well. So old value से हम start करेंगे. Learning rate हमें given है. Partial derivative is something that you would need to compute. एंड पार्शियल डेरिवेटिव्स के लिए इक्वेशंस हमें दी हुई हैं, सो इसको यहीं पे लिखा रहने देते हैं एक्चुअली. You are given equations for the partial derivatives with respect to a and with respect to b. आपको दोनों के लिए given है for the objective function. So I will compute my partial derivatives then. Let's do it for the very first iteration let's do it for a first. A के लिए you have 1 over n times sum of well I till n f of xi minus yi multiplied by xi. So ये आप क्या कर रहे हैं? fxi is the predicted output minus yi is the actual output multiplied by xi, which was the well input जो आपको दी हुई थी. So let's do this. For the very first instance, eventually you multiply it with 1 over 4. हम इसको, we can just divide the entire thing by 4 at the end as well. With respect to a. So first we're doing this for a. So this is equal to, I will divide the entire thing with 4 at the end because 4 मेरे पास data points है, and then I will compute this equation for every single data point. So पहले data point को ले लेते हैं. fxi हमने निकालना है, which is simply ax plus b. So x is equal to 4. A की initial value भी मुझे 1 given है. X is equal to 4 plus, actually इसको ऐसे लिख लेते हैं, 1 times 4 plus b is equal to 1 initially as well. So this is what I have, and with that I'm doing minus, I'm subtracting from it the original ground truth, which is equal to 8. So this is just for one single data point. Then I will need to multiply this with xi, and xi मुझे दिया हुआ था as 4. This is what I'm doing. And then I will add to it जो भी मेरा next data point है essentially. So my next data point is actually this one, 7 comma 11. Now my ground truth was 11 and x is equal to 7. A and b are still 1 because I'm still doing the very first iteration of my gradient descent algorithm. तो यहाँ पे मैं इसको multiply करूँगी by 7. Then I will add the third data point to it, which is 6 comma 4. So I will plug in 6 over here, and my ground truth is 4. I will multiply this with 6 as well. Then I have my last data point, which is 10 comma 14. So यहाँ पे I will have 14 and I will replace this with 10. So ये जो पूरा result आ जाता है, I will divide this by 4 eventually. Let's change the brackets. This is getting a little confusing. So my partial derivative with respect to a then comes out to be minus 11.25, and I'm gonna do the exact same thing for b as well, except के b के लिए आपको ये वाली चीज given है, you're not multiplying it with xi. So this is like really simple for me. सिर्फ जहाँ पे मैंने xi से multiply किया है हर term को, I can just get rid of that and everything else shall remain the same. So my answer comes out to be minus 1.5. When you have computed these partial derivatives, so you will update these weights then. I will tell you about one common mistake and how you're gonna make sure you avoid it. अब आप ये वाला algorithm apply कर रहे हैं, your gradient descent algorithm. If I can just get this over here, तो इसको हम add कर देते हैं. We'll just, there you go. This is what I was talking about. This is what you are doing with every single of your parameters. We will do this for both of our parameters. I think that this is gonna be a little bit simpler. All right, let's see. So सबसे पहले हम a की updated value निकाल लेते हैं after the first iteration. So updated value of a equals initial value of a minus learning rate multiplied by जो ऊपर हमने partial derivative निकाला था of j with respect to a. So this is going to be equal to the initial value of a was 1 minus the learning rate was given to you as 0.05 and the partial derivative for a we computed to be minus 11.25. So your updated value comes out to be 1.5625. Similarly हम b की updated value निकाल लेते हैं. So the initial value of b, and obviously this is going to be exactly the same. Initial value of b was also 1. The learning rate is still 0.05. And जो b के लिए हमने partial derivative निकाला था, that was minus 1.5. So this actually comes out to be 1.075. You have completed one iteration of your gradient descent algorithm. जब आपने second iteration करनी है, so you will be using these updated values of A and B. One common mistake over here is कि आप A के लिए अगर ये math पहले perform कर लें और फिर आप यहाँ पे B का partial derivative निकालते हुए A की updated value use कर लें as opposed to this value of 1, so your answer is gonna be wrong. You cannot update one variable like that. आप दोनों वेरिएबल्स के पार्शियल डेरिवेटिव्स निकालते हैं एंड आप दोनों वेरिएबल्स को पैरेलल में अपडेट करेंगे बिफोर यू मूव ऑन टू द सेकंड आइटरेशन. I will not do the second iteration right now. Even if you know and understand how to do this, I will still encourage you to do it on your own later as well. So this is what we've done over here. See, ये आपके पास first iteration के बाद values आई and then second iteration में आपने सिर्फ उन updated values को use किया to further update these values. Are there any questions up until this point? All right, so there is one last very important thing that I want to cover. I will take a few more minutes of your time now. Classification matrix, and well, you should know how to compute these matrix, but you should also know when which one is more appropriate for you. So accuracy तो आप calculate करते हैं by taking the total number of values predicted correctly divided by the total number of values themselves, which translates to true positives plus true negatives divided by true positives plus true negatives plus false positives plus false negatives. Then you have precision, which is also called your true positive rate. It's your true positives divided by true positives plus false positives. Then you have your recall, which is true positives divided by true positives plus false negatives. Precision में आप ये देख रहे हैं कि of the total values that were predicted as positives, how many were actually positive. Recall में आप ये देख रहे हैं कि of the total values that were actually positive, how many did you correctly catch? These are two very different things. F1 score is the harmonic mean of precision and recall. So 2 times precision times recall divided by precision plus recall. There is one last metric that was introduced to you in class, the area under curve of the, well, ROC. ROC is a curve जो true positive rate और false positive rate के लिए बनता है. And the area underneath this curve tells you about the ability of your model to rank your predictions. अगर एक certain threshold को change किया जाए. For instance, by default, the threshold is 0.5. 0.5 and above वाली values को 1 का label देंगे. 0.5 से कम वाली वैल्यूज को जीरो का लेबल देंगे. सो दिस टेल्स यू कि उस थ्रेशोल्ड को अगर आप चेंज करें तो हाउ डज दैट इम्पैक्ट योर ट्रू पॉजिटिव रेट एंड योर फॉल्स पॉजिटिव रेट. इट मीन्स के लाइक one thing is कि आपकी value 0.9 आई थी and you classified it as positive. Another thing is कि this is a true positive, but then there could be a true positive जिसके लिए value 0.51 थी and it was a positive. So this is something that your model was barely able to catch. I will tell you when to use each metric, when each metric is most meaningful to you. Accuracy is something that you use when your data set is balanced and when your errors are going to be equally costly. Precision is something that you use when you care more about avoiding false positives. That means कि जो legitimate items हैं उन्हें आप incorrectly flag करना avoid करना चाहते हैं. Let's go back to precision का formula. True positives divided by true positives plus false positives. If you want to avoid false positives and you want to evaluate that for your model, so you're gonna look at the precision, then you're gonna prioritize precision. Recall में you care more about catching all the positives. Even if you are raising false alarms, you want to make sure कि जो actual में positive cases हैं वो miss ना हो. One very important example of that are medical diagnosis. Um, so, for instance, if you are building a model that is detecting cancerous cells, maybe it is acceptable to you कि कुछ cells को वो falsely cancerous कह दे, लेकिन it is highly alarming for you अगर वो cancerous cells को miss कर दे. You want to make sure that your model is at least catching all the positives. प्रिसिशन में यू आर मेकिंग श्योर कि आप फॉल्स पॉजिटिव्स को अवॉइड करें. फॉर इंस्टेंस आपके पास कोई सिस्टम है दैट इज प्रिडिक्टिंग वेदर अ पर्सन इज अ क्रिमिनल और नॉट, तो यू वांट टू रियली अवॉइड फ्लैगिंग legitimate people by this system. Then you have the F1 score. F1 score is something that you use when you want a balance between precision and recall. This is something that we particularly use on imbalanced data sets as well. An even better measure is the area under the receiver operating curve, ROCA. You see, if you want to evaluate the model's ability to rank predictions instead of just assigning labels, you use this. This is useful when comparing models on data sets that are very imbalanced. I will give you a couple of examples and then we'll conclude. So, a wildlife conservation group is using a model to detect endangered species from camera trap images. Missing an actual sighting is something that could, missing an actual sighting is something that could hinder conservation efforts. So, an actual sighting would be a true positive. We are prioritizing true positives in this situation. हमने ये explicitly कहा है कि you don't want to miss actual values that are positive. And if we quickly go back, we will see कि इस case में you use recall. You care more about catching all the positives, even if you raise false positives. So you're gonna use recall over here. Missing an actual sighting could hinder conservation efforts, even though आप कोई false sighting का alarm raise कर भी दें. Secondly, an e commerce company is flagging user reviews as fake or as genuine. Too many false flags could annoy legitimate users. False flags are false positives, and you want to avoid false positives, in which case you use precision. You care more about avoiding false positives. Third one, a news website's comment moderation tool must automatically filter hate speech. Letting hate speech through is worse than filtering innocent comments. So, letting hate speech through would be, अगर आपने hate speech को flag करना है, तो that is a positive. If you are letting hate speech through, so it means that that is a. Oh, this is worse than filtering innocent comments. Filtering innocent comments would mean ke false positives. So letting hate speech through are your इसका मतलब है you want to catch the actual positives. even though आप बेशक कुछ innocent comments को, if even if you let them go, you want to make sure you're catching all the positives, even if some of the positives are false. In which case, again, we'll use recall. A company is testing different classification models on a data set with a 95:5 class imbalance. The goal is to identify the best model overall. जब आपके पास इतना balance हो and you want to identify the best model overall, you're going to use the area under curve. Your last example is a disaster alert system that classifies whether to issue a warning based on sensor data. Both false negatives and false positives are highly undesirable. When you want a balance between these, you prioritize your F1 score. All right, that will be all from my side. Good luck with your upcoming exam. If there are any problems, please do reach out.